So lesson number 2 continues on factoring of common factors. So in the last lesson we looked at the greatest common factor, pulling it out of each term of a binomial or a trinomial. What we're looking at this time is sometimes my common factor is also an expression. It can also be a binomial or a trinomial. So for example, if I look at class example number 1, this right here is all considered to be one term because it's a product of two terms. This is also one term. So I have two terms in this expression. What do they have in common? What does each term have in common? This is the same in each term, correct? So what I could do is I could now factor out that entire expression. If I take x plus 7 and I divide it by x plus 7, what would I get? 1. If I take something and divide it by itself, I always get 1. So when I take it out of this term, I would be left with 4x. And when I take it out of this term, what would I be left with? And it would be a minus 3 because of the minus above or in front of it. So that term factored becomes x plus 7 times 4x minus 3. So if I look at B, what does each term have in common? 3 minus 2y becomes my common factor. So my common factor is not limited to being just a monomial. My common factor could in fact be a binomial. If I factor out this 3 minus 2y, what am I left with?
7 plus 2y.
Good. So if I look at C, what does each term have in common? And when I factor out the 4a plus 1, what am I left with? Okay, so I'm left with a 9a here
Plus 1.
and a plus 1 from here because 4a plus 1 divided by 4a plus 1 gives me 1. So those are the tricky ones. We get the 9a, but we forget about the plus 1. Okay, we'll continue on. What's common in A?
3y plus 2.
So if 3y plus 2 is the common factor, when I factor it out, what am I left with?
5y plus 1, 4y.
Can I simplify that second term?
Yeah, it's 9y.
And so I would simplify it. I would rewrite this as 9y plus 1. So if I can collect like terms within a term or within a factor, I collect the like terms within that factor. Okay. What is common in B?
6.
And what does that leave me with?
3a minus 9.
What can you tell me about 3a minus 9? Is there anything that I can factor out of that?
3.
I can factor out a 3. So I would take the 3 out. I would put it right at the very front because order doesn't matter when I multiply. So if I want to, I could rewrite it this way. And if I factor out a 3, what am I left with? A minus 3. Or it could be written as 3 times a minus 6 times a minus 3. So the order doesn't matter with the exception that the 3 would go to the front. my monomial products will always come before the binomial, or my monomial factor will always come before the two binomials. So in class example number 2, you have to look for things like being able to simplify or being able to remove another common factor because of this part right here. Writing the answer in simplest factor form. So 5y plus 1 plus 4y is not simplest form. 9y plus 1 is. 3a minus 9 is not simplest form. 3 times a minus 3 is. So I need to keep making sure that this is completely factored. I can't remove a greatest common factor. There's nothing in common with both terms. I keep moving down. What do you notice about C?
It's x minus 5 and 5 minus x. So it just flips.
Are these the same factor right now? No, they're not the same factor. But how can I make this the same as that? Well, if I rearrange it, first of all, so it actually has an x and a 5. I get to that point. How can I make my negative x a positive x? Times it by a negative. So I have to times this whole thing by a negative, or the other way to look at it, I have to factor out a negative. So if I factor out a negative 1, my positive 5 would become a negative 5. My negative x is now a positive x, and my positive 5 is a negative 5. Now I have a common factor. X minus 5 is common to both parts. So I can factor out the x minus 5, and I'm left with a 2x minus 5. And I can now do the same thing here, this 3 minus x. If I factor out a negative 1, my negative 4 would become a positive 4. My negative x will become a positive, and my positive 3 will become a negative. So I kind of skipped a line in there. Now I have x minus 3 is common to both terms, so I can factor it out. Leaves me with a 20x plus 4. And if I look carefully at the 20x plus 4, what do I notice? By 2 and 4. So I could factor out a 4. And if I factor a 4 out from this term, what would I be left with? 5x plus 1. Five minutes. 1, A, E, and I. The next section looks at factoring by grouping. When we have 4 terms, most of the time when we have a polynomial that has 4 terms, we can group them into 2 pairs. And then we can factor between those 2 pairs. So for example, if I have x squared plus 3x plus 6x plus 18, if I look just at the x squared and the 3x, what do these, because all 4 terms don't have the same thing in common. That's why we look at them in groups of 2. I can't pull the same thing out of all 4 terms. But does x squared and 3x have something in common?
2x's.
Is it 2 x's or just 1? This is an x squared and this is an x. So what could I factor out? 1x or 2x? I could only factor, no? I can only factor out what? Like x squared is written as x times x, and 3x would be written as 3 times x. So what do they have in common? X is their common factor. So I could factor out an x. And if I factored out, so divided or took out an x, what would I be left with? So x squared divided by x. X plus 3. Okay. Now let's look at the next two terms. 6x plus 18.
6.
I could take out a 6. And if I take out a 6, what am I left with?
X plus 3.
What do you notice? I now have another common factor. So I've taken what is here, 4 terms, and I've brought it down to 2 terms that have a common factor of x plus 3, leaving me with x plus 6. So with the 4 terms, it was not possible for me to factor out the same thing from each of the 4 terms, but I was able to factor out from the pairs. I could take out a common factor from the x squared and the 3x. I could take out a common factor from the 6x and the 18. And because the way the question is written, I end up with another common factor, which I can then pull out of the 2 terms. So we're going to repeat this in all 5 more examples. So if I look at these 2 terms, 8x squared minus 2x, what is the common factor? 2x. And if I factor out a 2x, what will I be left with? 4x. Take away 1. 4x minus 1. Now look at the next 2 terms. 12x and negative 3. What could I factor out?
3.
And if I factor out a 3, what do you suppose I should be left with? 4x minus 1. The whole purpose of doing these questions is to be able to factor out a common factor and to then factor out another common factor until I can't work down anymore. So 4x minus 1 is the common factor to these 2 terms, which when I remove it, I'm left with a 2x and a 3. Okay, I'm going to give you a minute. I want you to do just C. So what do the first 2 terms have in common?
4A.
4a. So if I factor out a 4a, what would I be left with?
2A minus 1.
Now, what do you suppose I should be left with after I factor something out of the next 2 terms? I want to be left with a 2a minus 1. So when I go to ask, what should I factor out? What do 10a and 5 have in common?
5.
5. Do I take out a positive 5 or a negative 5?
Negative 5.
I take out a negative 5 so that this negative 10a divided by negative 5 will leave me with a positive 2. If I take out a negative 5 from the positive 5, I'll be left with a negative 1. So the key here is to basically try to, if you can, force a common factor in place. 2a minus 1 is my common factor. 4a minus 5 is what I'm left with. Try D. To 6a squared minus 9a.
3A.
Okay. And what am I left with?
2A minus 3.
And when I take a look at the next 2 terms, the next 2 terms are already a 2a and a 3, but they're the opposite side.
Take out -1.
Take out a -1, good. And now I forced that 2a minus 3, which then becomes my common factor, leaving me with 3a minus 3. Would I leave it like that? Why are you shaking your head no, Tyrone? Oh, sorry, 3a minus 1. That would be why.
Yeah.
That would be why you're shaking your head, because I wrote it wrong. Okay? E just has letters. We approach it the same way. What does P, Q, and PR have in common?
P.
P. So if I take out a P, what am I left with?
Q.
Q plus R. What does negative SQ and negative SR have in common?
Negative S.
A negative S. And I take out a negative S because I want this to be a positive Q. And then this will make this a positive R. And then Q plus R is my common factor, leaving me with a P minus S. What happens when we approach F?
First through R and let's say
Do I have a common factor here?
no.
Do I have a common factor here?
No.
Oh, well, sort of. I could take out a 3x.
Yeah.
But if I don't have a common factor with these two terms, I'm not going to be able to do the same steps that I've been doing before.
15x squared and 5x squared.
Oh, so can I? You're saying I can rewrite this? Yeah. Oh, I could. So what would I group together?
5x squared minus 15x squared.
Why that one?
Because 5, 15,
5 and 15 have common number factors, and 18y squared.
common number.
Okay. And you know what I'm going to do? I'm actually going to put negative 6x in front of it. I'm going to go like this. And then I'm going to ask you why I did that.
Because you wanted to.
But there was a reason why I wanted to. What's the reason why I wanted to?
Keep 18 positive.
No. 18 would have been positive anyways because it's got a plus sign in front of it.
Because goes first then y.
Yeah, because x is first in this one and then the y squared. So I want to make sure the y squared is kind of, I want to follow the same pattern. So if I have something and then y squared and then something and then y squared, my y squareds are going to match up. And when I go to then do my grouping, I'm not going to have something backwards. And I'll show you what I mean by that afterwards. So what can I factor out of these two terms?
5x.
And what would I be left with?
X minus 3y squared.
What would I factor out of the next two terms?
Negative 6.
Which would leave me with?
X minus 3y squared.
Right. So I have x minus 3y squared is common to both terms. And I'm left with a 5x minus 6. Now, to show you what would happen, if I press the keyboard keys, that's what would happen. Okay. 5x squared minus 15xy squared plus 18y squared minus 6x. So if I had written it out in this form, factor out my 5x, and I'd be to that point. Then when I look at my 18y squared and my negative 6x, this is where things would start to get messy.
I guess you think you just have to put 6.
Yeah, because I might just factor out a 6, in which case I'm left with y squared minus 3x. And then I look at these two, I did that wrong. 3y squared. minus x. There we go. So now when I look at these two factors, it's like, well, they're kind of the same, but not really. But then I go back to that, well, if I make this a negative 6, then I have a negative 3y squared and a positive x, which I can then rearrange. And now I'm back on track. But it took me 3 more lines. So when you have to rearrange your 4 terms to make your groups, you want to do this in a way that it's going to make sense. I put 5 and 15 together because I know I can pull out a common factor. 6 and 18 have common factors. And then, like Raylan said, I put the y squared here because it matches up where the y squared is in the first 2 terms. So 1, 2, 1, 2. Okay, I want you to do questions 2A and E. 3B and E, and 4A and B. I'm going to add questions 10 and 12 because we're not going to do the back side of the page. The back side of the page is more so enrichment, so we'll do 10 and 12.